All right, bell work today is going to actually directly lead us into tomorrow. All right, so while a good problem, it is more important for tomorrow as to where we're headed. Okay, so we got one more big lesson tomorrow, a little lesson Thursday, some review Friday, and then test on Monday. That's where we're headed. All right, so K is just a constant, so keep that in mind. K is a constant. And move only Y and dt on the first step. Now, you could have done more and gotten the same correct answer, but I'm going to show you what I'm doing here. Okay, this equation right here is directly proportional. Okay, that's what this is set up as directly proportional. For an example, if your y goes up, what is going to happen to this value over here? It's also going to go up. It's directly proportional. Okay, this setup is a directly proportional equation. If the y increases, this thing's going to increase. And we'll look at that here in a second. That's important. Okay, so my first step, I said move y. So I'm going to divide both sides by y. And I'm going to multiply by dt. So over here, dt cancel. Over here, the y's cancel. So I get dy over y equals k dt. We separated first. That was step one. Once we separate, what am I going to do next, Caden? Integrate it. We're going to integrate. What is the integral of dy over y going to get me? ln. So this right here is ln, absolute value of y. On the other side, I'm taking the antiderivative of k dt. What is the, k is a constant. What is the antiderivative of k dt going to get me? kt in this case. Yes, kt, because it is with respect to t. But we're going to write kt, because it's just a number, like 3. What's the antiderivative of 3? It'd be 3x. Here, k is a constant. Oh, okay, cool. It's kt. What else do I need to include there? Plus c. So we separated, we integrated. The next step would be solving for c. Now, in this case, we're not going to solve for c because they didn't tell me any starting point. We're just going to go ahead and get y. Again, 90% of the time when we do this, they'll allow us to solve for c. Here we didn't. That's okay. Okay, I'm making a point more than anything. So now we're going to solve for y. So if I'm solving for y here, Zachary, what do you want to get rid of next? Yep. How do I get rid of that natural log? E. I'm going to raise both sides to the e. So over here on the left side, it's going to cancel the absolute value of y. On the right side, I'm going to make you a little bit frustrated with this, but we could just leave it like this, and this would be totally cool. But let me show you something here, and it's going to help us here in a second. But if I rewrote this as e to the kt plus e to the c, or I'm sorry, times e to the c, would you agree that that's the same thing? Those are the same thing. What is e to the c going to be? Yeah, it's a constant. Would you agree? That's just a number, right? E is 2.7 to some power. This is just a constant. Just for the sake of ease, I'm going to call that the letter A. This new constant, it's just a constant. I'm going to call it the letter A. You're going to see why here in a second. A equals, or I'm sorry, A times e to the kt. What else do I need to do here to get y by itself? Plus or minus. Y equals plus or minus a e to the kt. Does that look familiar to anybody? Yeah. Y equals plus or minus AEKT. You have seen that formula right there in Algebra 2. You've seen it in pre-calc. You've probably also seen it in chemistry. That thing right there is a half-life formula. And you might not like half-life. It's not hard. We're going to do it tomorrow. It's pretty easy. Okay, you did it in Algebra 2. So if you can do it in Algebra 2, you probably are going to be able to figure it out in calculus. You've got a little more brain power now. Okay, but that's half-life. How about this formula? Have you ever seen this one before? A equals P-E-R-T. Yeah, that's compound interest, right? You saw that one in Algebra 2. You've seen that one in Econ maybe. Okay, but that's compound interest. This right here are the same. So if you might be like, oh yeah, half-life's really ugly, compound interest is. And they're the exact same formula. They just changed the letter. Okay, instead of A, they use P. Cool, same thing. Kind of makes sense what's happening there. We started with a directly proportional relationship, and when we integrated it, we got back to these formulas that we've seen a bunch of times. We'll do that tomorrow. All right, so today we're going to focus on free response questions, specifically about differential equations. Obviously, that's what we're doing in this chapter. Okay, this question right here, this first one we're doing is from 2018. So from 2 years ago, they gave this question. The AB average was a 3.45. So across the nation, every student that took this question, they averaged the whole thing, they got 3.45. That's pretty high for an AP question. But if we can be better than a 3.45, we're going to win. The whole goal is to beat everybody else across the nation. If we get a 4, we win. Okay, so that's what we're trying to think about. So number 6, here's the base directions. It just says consider the differential equation, this guy right here. Cool. They gave me the derivative. Given that derivative, it says a slope field for the given differential function is shown. So this is our slope field. Sketch the solution curve that passes through the point 0, 2, and sketch the solution curve that passes through the point 1, 0. Do that. You got 2 points. You got 0, 2, and you got 1, 0. Sketch the solution curve. Or in other words, drop your boat and draw the picture. Go. Show me with your arms, what does the solution curve look like through the point 0, 2? It's the easiest AP point you've ever gotten. You get 1 point if you just draw a straight line. All of the slopes that point touches are a straight line. We draw a straight line. We just scored 1 point. Okay. Point 2, we're going through that dot. Show me with your arms. What does that graph look like? Oh, yeah, you guys look super cool now. There's a bird. We're going to look like this. It's taking me up and to the right, and it's going to flatten out. Down to the left, we kind of flatten out, and then we start coming back up into that direction right there. You don't have to be perfect, but if you drew a shape that generally looks like that, you just scored a second point. Okay, 1 point for the pink line, 1 point for the second line. We're up to 2. The national average was a 3.45. We already got to 2, and we haven't done anything else yet. Yes, ma'am.
I forgot if you said that we have to draw arrows or not.
It doesn't matter if you draw arrows or not. You're always going to try to go all the way across the picture, so as long as it goes all the way across, don't stop in the middle and draw an arrow. Questions on the first one? Letter B says, let y equals f of x be the particular solution of the given differential equation with the initial condition that f of 1 equals 0. Write an equation for the line tangent to the graph of y equals f of x at x equals 1. Write an equation for the line tangent to the graph at x is equal to 1. Do it. That's not difficult. Talk with your neighbor if you need to. Get an answer. Let y equal the particular solution, but we're writing an equation of the tangent line. As soon as you see the phrase, write the equation of a tangent line, what should you write? Y minus equals x minus. Do we know? In order to do that, that is called point-slope form. I need a point and a slope. Do I have a point? Yeah, 1, 0. So plug in 1 for x, y is 0. The other thing I need is a slope. How am I going to find the slope that goes right there? They gave me the slope equation right up there. Okay, right up there it says dy over dx. And they use this writing style on the test sometimes. I think it's helpful. But the derivative, and then they are going to plug in. So they do like this little like subset. So like down below, subscript, the ordered pair 1, 0. So what is the derivative when I plug in 1, 0? And so I'm plugging into this guy. It's 1/3. My x value is 1. My y value is 0. Show me with your fingers. You can't show me with your fingers. Just kidding. -2 squared is going to get me 4. 4 times 1 times 1/3. My answer is 4/3. That's my slope. If you got that right there, you scored a point. If you then wrote 4/3 right there, you scored a second point. 1 point for your derivative, 1 point for the answer. We're already up to 4. We haven't done anything else yet. The national average was 3.4. We're already up to 4, and we haven't even done the differential equation question yet. Everybody good to this point? Part C says, find the particular solution to y equals f of x given the differential equation and with the initial condition of f of 1 equals 0. What does that mean we're doing? Sikio, separate, integrate, solve for C, solve for y, and options. Get started with that. Go. We're going to start off by separating. No, I'm sorry, I drew an integration sign when I said separate. Separate it. So if I'm separating here, what am I going to do, A and B? Yep, move the dx over. So I'm going to get 1/3 x dx. What's going to come to the left side? And where's that going to go? On the bottom. So I could say divided by y minus 2 squared. or I could write it as y minus 2 to the negative 2. This is not a natural log question. Okay, it is not a natural log question. How do we know that this is not a natural log question? It's to the second power. If it's to the first power, yeah, it's natural log, but it's the second power. Don't make it natural log. You love it. Don't do it. Okay, so this is just y minus 2 to the negative, or to the negative 2 power. That's my separate. Once I've separated, then I'm integrating. Y minus 2 to the negative 2 power. Add 1 to, this is mental u sub. Add 1 to my exponent. Divide by my new exponent. What's the derivative of y minus 2? What's the derivative of the inside? Just 1. So I don't have to do anything else there. Okay, that is a mental u sub problem. Okay, it looks kind of weird to be able to do that, but we can do that here because it's just y minus 2. Because the derivative of that is just 1, we can do that setup. Okay, on the other side, 1/3 x, I'm adding 1 to my exponent, dividing by my new exponent, and a plus c. If you got that, we just got 3 more points. We got 1 point for the separation, and then 2 points for the integration. Or actually, I lied. It's 1 point for the integration. 1, 2. Everybody good to hear? Then we're solving for c. We take 1, 0, we plug it in. So I'm taking 1, plugging it in for x. We're taking 0, plugging it in for y. 0 to the negative 2, or 0 minus 2 is negative 2. What is the negative 1 power going to do to my negative 2? It's 1 over. It's 1 over negative 2. And then I have a negative sign. So this is 1/2 equals 1/6 plus c. I'm going to subtract 1/6. So I'm taking 3/6 minus 1/6. My answer is 2/6, or 1/3 is my c value. We separated, we integrated, we solved for c. Okay, we are up to 4 points now in this question. You've scored 4. Okay, 1, 2, 3, 4. Yes, ma'am. Because it was negative 2, and I flipped it, so that becomes negative 1/2, and then it's times the negative, so it becomes a positive 1/2. Other things, separated, integrated, we solved for c. Now you're going to solve for y, so negative y minus 2 to the negative 1 equals 1/6 x squared plus 1/3. Go ahead and get y by itself. Keep going. All right, here we go. We are trying to get y by itself, so if we're getting y by itself, Austin, what'd you do next? Yeah, move that negative sign, so we're going to change all our signs over here on the right-hand side. So it's negative 1/6 x squared and a minus 1/3. Cool, we did that. Then what, Evan? Yep, I'm going to raise both sides to negative 1. And he said it correctly. We could just do this and raise both sides to negative 1. That totally works, and you can just leave it like that. This is calculus. You don't need to simplify. Or you could say, all right, I'm doing the reciprocal. He's going to flip the left-hand side, and he could flip the right-hand side by just doing this. Remember, it's calculus. We don't need to simplify. As ugly as that is, great. Who cares? What else would I need to do to simplify? Add 2. Y equals 1 over negative 1/6 x squared minus 1/3 plus 2. Super ugly. Okay, if you look at what they got for an answer, this is what we got. That's what they got. Theirs is cleaner. I don't care if it's cleaner or not. We got the right answer. It's calculus. We don't have to simplify. Questions on that? Again, scoring wise. Okay, you can see how they scored. You got 1 point for separating, 2 points for the antiderivative, 1 point for figuring out C, and then 1 point for your answer. Questions on that? If you were given this question on the AP exam, can you see how you could beat the average score of 3.45? Definitely. On most of them, if you get started right, now I know that there's some spots on C that are a little bit challenging, but if you get that start, you're going to get up to 9 points on that thing pretty easily. Flip that paper over to the backside. Okay, this question is from 2008. The national average was 3.7 because the first couple points were pretty easy. Consider this differential equation. On the axes provided, sketch a slope field. Go. Sketch that slope field. Sorry, this is what I get for skipping the question halfway through. I did not read part B all the way through. I changed my problem in the middle of the day, so I missed this. It then said we didn't do this part. Use your equation to approximate 0.7. So we have this equation right here on part B. We want to approximate 0.7. So what are we going to do with that equation to approximate 0.7? Plug it in. All we need to do here is plug it in. So it's just y equals 4/3 0.7 minus 1. If this is the AP test, put a box around that question. Okay, this is the approximation. F is of 0.7 is approximately that guy right there. You don't need to do the math. You can just leave it. Okay, that is totally fine for an answer. Okay, we got that point. That is all an approximation is plugging it in. Okay, don't make that be harder than that. I apologize. I just missed it as we were going. Keep working on that slope field. There's your slope field. You should have a slope line of 0 right through the middle here. So right through the middle, you should have a slope line of 0. On top, you should have a slope of 1, a slope of 1, and a slope of 1/4. On the bottom, you should have a slope of -1, a slope of -1, and a slope of -1/4. If you got this whole row correct, you scored 1 point. If you got this row and that row correct, you scored a second point. I'm not positive, but I believe that if you just missed one on the orange line, then they would still give you credit. Okay, but don't make a mistake. Make sure you're doing that correctly. Questions on A. Part B says, find the particular solution to y equals f of x of the differential equation with the initial condition f of 2 is equal to 0. So what does that mean I'm doing with this guy? Sikio, separate, integrate, solve for C, solve for Y options. Okay, go ahead, work your way through that as you find your C. Show it to me with your fingers. Go. We're separating first. So if we're separating, we're going to multiply both sides by dx and divide by y minus 1 because that's all on top. So it's dy over y minus 1 equals dx 1 over x squared and then a dx. Okay, you can write it however you want, but that is my separation step. Okay, step 2 is integration. So if I'm integrating the left-hand side, what is it going to be when I integrate dy over y minus 1? That is ln. This time it is ln because y minus 1 is to the first power. So ln, absolute value, y minus 1 equals. On the left side, if you don't like 1 over x squared, neither do I. Write it as x to the -2. Add 1 to my exponent. Divide by my new exponent. That's not ln because it was x to the second power. It can't be ln. It's x to the -2. Okay, divide by my new exponent, throw a plus c at the end. That's my separation. 1 point for separating, 2 points for integrating. We're up to 3 points. Everybody good at that point? Then we're going to solve for c. So if we're solving for c, we're plugging in 2 and 0. So I'm plugging in 0 over here. And over here, I'm plugging in 2. 0 minus 1 is -1, but it's the absolute value of that, so it's a positive 1. What is the natural log of positive 1? Natural log of 1 is 0. 2 to the -1. It flips it to make it 1/2, and then it's negative. So when I move that 1/2 over, 1/2 is C. Questions to there. We separated, we integrated, we solved for C. My next step is solving for Y. So I'm plugging back into this equation, the natural log, absolute value, Y minus 1 equals -x to the -1 plus 1/2. We're going to solve this thing. Maddie, what do you want to get rid of next to solve for Y? The natural log, how do I get rid of that? Yep, we're going to do e to both sides. Raise both sides to the e. That's going to cancel. So I get absolute value of y minus 1 equals e to the -x to the -1 plus 1/2. Remember, you do not have to simplify. There's not really a whole lot of simplifying I can do here, but I don't need to do anything besides just write it. Don't let the simplifying part throw us off. Luke Johnson, what do you want to do next? Plus or minus, get rid of those absolute values. Take the plus or minus on both sides. Those cancel. Y minus 1 equals plus or minus e to the -x to the -1 plus 1/2. Last thing I got to do is get rid of the -1, so add that 1. We separated, we integrated, we solved for C, we solved for Y. Last thing we've got is an option. I want to be able to plug in the number 2, and when I plug in the number 2, I need to get 0. So what do I want to have here? When I plug in 2, I want to get 0. If I plug in 2, 2 to the -1 would flip it to make it 1/2. Then it would be a -1/2. -1/2 plus 1/2 would be 0. e to the 0 is 1. Do I want to be 1 plus 1 or 1 minus 1? Minus, because I'm trying to get 0 in the end. So my answer is y equals 1 minus e to the negative x minus 1 plus 1/2. That's my 5th point there. Or actually, I lied to you. They gave them 6 points on this one. 1 point if you just included plus c. If you wrote plus c, you scored a point on that one. They gave you 6. Everybody good to there? Last one for that particular solution. So even if you got it wrong, it's saying use that particular solution. We want to find the limit as x approaches infinity, and that looks really scary. It is a super easy point. Limit as x approaches infinity of 1 minus e to the negative x to the negative 1 plus 1/2. We can have all these rules with limits, but remember, how do I find a limit? If there's a number here, or even if there's an infinity, what am I going to do with that number? Plug it in. We take infinity, we plug it in. Okay, so if I plug it in, I get 1 minus e to the negative x to the negative 1. What does x to the negative 1 really mean? 1 over. 1 over infinity plus 1/2 up in the exponent. What is 1 over infinity as a number? A really small number, basically 0. So that's basically 0. So I don't care about it. My answer is 1 minus e to the 1/2 power. That's it. We plugged in infinity. It's 1 over infinity, which is basically 0. So my answer is just that. You scored 1 point if you got to that. Is that weird? Yeah. But can you do it? Sure. It's just plugging in infinity.